Hi, fifth graders. Today we are working on Chapter 6, Lesson 6.4 with common denominators and equivalent fractions. This lesson can be found on page 369 in our textbooks. And the standard that we are working on in this lesson is a number operations fractions 5.1. It is a little bit further down where we are finding like denominators with this lesson. So our essential question on page 369 is, how can you rewrite a pair of fractions so that they have a common denominator? Under Unlock the Problem, it says, Sarah planted 2 one-acre gardens. One had 3 sections of flowers and the other had 4 sections of flowers. She plans to divide both gardens into more sections so that they have the same number of equal-sized sections. How many sections will each garden have? So you can use a common denominator or a common multiple of 2 or more denominators to write fractions that name the same part of a whole. So we introduced how to find common denominators when we did our lesson over our least common multiples. So one way to figure out a common denominator is to multiply the 2 denominators together. Now when we do this method, this does not always give us the least common multiple between the 2 denominators, or what we would then call the least common denominator. So any common denominator can be found by multiplying the 2 denominators together. So if I'm taking the denominator of 3 and 4, 3 times 4 is 12. And then I would go ahead and write both of those fractions as equivalent fractions using that common denominator of 12. So I always take away this equal sign right away, and I'm going to put a multiplication sign because I want to show how I am changing both of these fractions to have those denominators of 12. So I know that we took 3 times 4 to get 12, and anything that I multiply the denominator by, I'm going to do the same thing to the top number, which we call the numerator. So I'm going to now take 1 times that 4 that we did, and that gives me the numerator of 4 for my new equivalent fraction. Doing the same thing to the 1/4, so I had 4 times 3 to get that 12. And again, anything that I do to the denominator, I also have to do to the numerator. So 1 times 3 gives me 3. So my 2 equivalent fractions for the 1/3 is the 4/12, and for the 1/4 is 3/12. So I now see that both gardens would have 12 sections. And then I can show a picture of this where I'm dividing for this first 1/3 sections into 4ths. So creating 4 equal sections inside each of these 1/3 pieces. And this is going to show my 12 equal sections. And then doing the same thing to the 1/4 size pieces, but this time I'm going to divide those into just thirds to show my 12 equal pieces. So now the first picture is showing the 4/12 because there are 1, 2, 3, 4 sections inside one of those 1/3 sections, and out of 12 total sections. Same way with the second picture, I now have 3 sections in the 1/4 section out of 12 total sections. Now another way is to use our list like we did when we were using the least common multiples. So we are going to make a list of the first 8 non-zero multiples of 3 and 4. So again, from our LCM lesson, we knew that we were just counting by that number. And if we were struggling by counting with that number, then remember we were multiplying So for multiples of 3s, we are multiplying 3 times 1, 2, 3, and then we're going to do that all the way up to 8. So they started our list for us for the multiples of 3s. We have 3, 6, 9, 12, 15, 18, 21, 24. And then same thing for the multiples of 4. They started counting by 4s for us. We're going to continue this out. So 4, 8, 12, 16, 20, 24, 28, 32. So now we obviously see that 12 was the least common multiple, so we already used the least common multiple to create equivalent fractions. But I also noticed that there's another common multiple that I have between 3 and 4, and that is 24. So we could create equivalent fractions also using 24. Now, I don't recommend using larger multiples normally. If you are easily able to find that LCM, the LCM is the best method to use, because when it comes to adding or subtracting, we will have to have our answers in simplest form, and the LCM is easier to use for my simplest form. So I'm going to go ahead and write my multiplication, put that new fractions denominator that I want to have. Remember, we said we are going to use 24 this time, just to show another set of equivalent fractions. So now for the 1/3, 3 times 8 equals 24. Multiply the numerator by that same exact number. 1 times 8 is 8. And then do the same thing for the 1/4. 4 times 6 gives me that 24. So I have to multiply the numerator by 6 as well. And we know 1 times 6 is 6. Now, when we are setting up these equivalent fractions, the reason why they are actually equal, and that's why we call them equivalent, is because we're setting the multiplication up as essentially multiplying the original fraction by 1. Remember, anytime you have a numerator and the denominator equaling the same thing, so for example 8/8, that equals 1 whole, because if you would have a rectangle with 8 sections, you would color all 8 sections in, so you are coloring in one entire strip of rectangles in. Same thing with 6/6. 6/6 again would equal 1 whole. You can also think of it as a division problem. A fraction symbol is a division symbol. So you would have your top number, the 8, divided by the bottom number of 8. 8 divided by 8 we know is 1. Same thing with the 6/6. 6 divided by 6 is 1. If I really wanted to show the picture to make it easy on myself, have that rectangle, split it into 2 equal pieces. The numerator tells me how many of those equal pieces to shade in. So you notice that I did shade in 1 whole rectangle. So that is why we are able to have them be equivalent fractions, because we are essentially multiplying both of those fractions by 1 whole. So we now notice that that garden can either have 12 sections, or if she wanted to make really small sections, she could have 24. Moving on to the next page, I've already mentioned this. We have what is called the least common denominator. And find the least common denominator of 2 or more fractions by finding the least common multiple, or we know that would be the LCM, of 2 or more numbers. So for this example, I do want to make sure that I am using the least common denominator, or we also could call that the LCD. And we want to do this by listing our non-zero multiples of those denominators to find that least common multiple. So we are using the fractions of 3/4 and 1/6 to find those the least common denominator between those 2 fractions. So listing my multiples of 4, 4, 8, 12, 16, 20, 24. And then I can list my multiples of 6. 6, 12, 18, 24. So I'm going to stop my list right here. I could have stopped it a while ago if I really wanted to. But I notice if I look at the multiples of 4 and 6, the LCM would be 12. So that would be what we would call the least common denominator, or the LCD. So I want to make sure I use my denominator of 12 to create those equivalent fractions. So notice they've already set up the multiplication for us. And for the 3/4, notice they are multiplying by 3 over 3, which is equivalent to 1 whole, because we know that 4 times 3 gives me that LCD of 12. And then any number that you multiply the denominator by, you do the same thing to the numerator, because remember, we want to make it equal to that 1 whole for that fraction that we're multiplying by. So now 3 times 3 equals 9. And then do the same thing to the 1/6. Again, I want to use that LCD of 12, and I know that 6 times 2 gives me that 12. So multiply the numerator by 2 as well, and 1 times 2 is 2. So 3/4 can be rewritten as 9/12, and the 1/6 can be rewritten as 2/12. Now, by doing this lesson, it is setting us up for the lesson over adding and subtracting fractions, because when you add and subtract fractions, you do have to have a common denominator before you can add or subtract. Under the share and show for number 1, they want us to find a common denominator of 1/6 and 1/9. Rewrite the pair of fractions using that common denominator. So if you need to, make sure you're listing the multiples on your paper. If you don't have to, if you can list these in your head and remember, that is okay too. I don't need to see the list every single time. So I am going to show the list for the 6 and 9, because I want to make sure that I'm using the least common denominator. I like to use that denominator instead of just any random denominator. So counting by 6s, I have 6, 12, 18. Counting by 9s, I have 9, 18. And I know right now that I can use the LCD of 18. Now, I could have multiplied my two denominators together like they wanted to, but again, I don't want to use that large of a denominator. If I would multiply my two denominators together, that would be 54, and I would prefer not to use that large of a denominator. So I am not doing just any common denominator. So I am going to set up my multiplication problem. And I know that I want to use the denominator of 18 for this. And now I'm going to show what I'm multiplying each fraction by to get that common denominator. So 6 times 3 was 18. I noticed that it was the third number in my list, so that's why I know it was 6 times 3. And then 1 times 3 to get the numerator, and that is 3. So 3/18 is the equivalent fraction for 1/6. Do the same thing for 1/9. I know 9 times 2 is 18. Multiply my numerator by 2 as well. So my equivalent fraction for 1/9 is 2/18. For number 2, I have the denominators of 3 and 5. If I wanted to list my denominators, I have 3, 6, 9, 12, 15. And for 5, I have 5, 10, 15. I notice that I do want to make sure that I am using 15 as my common denominator. I could have gotten that least common denominator as well by just multiplying those two denominators together. Sometimes that does work out for us. So for the 1/3, set up my multiplication problem, and I know that I want it to equal 15 for that denominator. So 3 times 5 equals 15. multiply my numerator by 5 as well. So that equivalent fraction is 5/15. I'm going to do the same thing for the 1/5. So set up my multiplication problem with that denominator of 15. And I know that 5 times 3 equals 15. So multiply the numerator by 3, and I now have 3/15 for that equivalent fraction. For number 3, showing my multiples, I have 3, 6, 9. Well, if I list my multiples of 9, I just have to list that very first multiple, and I already have my LCD. So I want to make sure that I'm using 9 as my common denominator. Again, you could have multiplied 3 times 9 together and got the common denominator of 27. You could have also used the denominator of 18 as well. That would have worked too, but I like to use the least common denominator. So for 2/3, set up my multiplication problem. Again, I want to make sure that denominator is 9. 3 times 3 gives me that 9. So multiply my numerator by 3 as well. So I have the equivalent fraction of 6/9. I want to make sure that I show you that technically, because my 5/9 already has that denominator of 9, I don't have to do anything because I've already had that common denominator that I said I wanted to use. Now, if you really want to show the multiplication, obviously 9 times 1 equals 9. Multiply the numerator by 1 as well, and that still leaves me with the 5. So if you wanted to show the multiplication, you can, but that multiplying by 1/1 is not necessary. The next question, number 4, listing my 9s, I have 9, 18, 27, 36, 45. For 15, I have 15, 30, 45. So I know my common denominator that I want to use is 45. Again, I really don't want to have to multiply 15 times 9 to get a common denominator for this one. So for my 2/9, setting up my multiplication problem, having that denominator of 45, I now can have 9 times 5 equals 45. Multiply my numerator by 5, and I get the equivalent fraction of 10/45. Do the same thing for the 1/15. I know that to get the denominator of 45, I'm taking 15 times 3, multiplying my numerator times 3, that gives me 3/45. Moving on to the next page. For the on your own, you can go ahead and pause this, try to come up with your equivalent fractions, and I'm going to give you some examples of what you can use. Again, you don't have to use my exact ones because there are multiple ways that you can create equivalent fractions. I am going to show you, for the majority of them, the least common denominator. So that is the denominator that I will be using. So for number 5, you could change the 5/9 to 25/45. For the 4/15, you would then have 12/45. For number 6, 1/6 would change to 7/42. And the 4/21 would be 8/42. For number 7, you could have for 5/14, 15/42. And for the 8/42, obviously, because that already has the denominator of 42, that would stay at 8/42. And for number 8, the 7/12 is 21/36. And the 5/18, I would have 10/36. So for 9 through 11, they have some missing information that they want us to fill in. So notice this time they want us to find the least common denominator. So we can list our multiples of 5 and 8. So we know 5, 10, 15, 20, 25, 30, 35, 40. Now if you can do this in your head, you don't have to show your multiples. For 8, I have 8, 16, 24, 32, and then 40. So notice that our LCD would be 40. For number 10, they did not give us one of the denominators for the fraction, but they do tell us that the least common denominator would be 15. So the easiest denominator to fill in for this 1 over blank, we do know that we would be able to use 3 as our denominator, because we know that 5 and 3 would both be have their least common denominator of 15, or you could have even used the denominator of 15 for that fraction as well. And for number 11, doing the same thing, well, if I have a denominator of 42, there are multiple different denominators that I can fill in under the 3 to have that LCD of 42. The first one would be 7, because we know 6 times 7 is 42. Another one would be 21, because if I listed my multiples of 21 and 6, the first number that they would both have in common is 42, and obviously 42 as well. So I am going to stop the lesson right here so I can go ahead and set up your homework problems. If you are still struggling with this, please make sure that you are re-watching our video lesson in order to help you out. So on your homework, the front page, you will be doing the evens only. So 2, 4, 6, 8, and 10. So notice for the top 3 questions, it says use a common denominator to rewrite an equivalent fraction for each fraction. Now when I have you go enter these into Schoology, make sure you're doing this along with the Schoology questions, because you may notice that it's not going to be a fill-in-the-blank type question, so you might have to use a specific denominator on this. For number 8, you do have to use the LCD to create this equivalent fraction. And then number 10, they do want to know just what the LCD would be between 2/3 and 1/2. You're not setting up the equivalent fractions. You're just going to list the LCD for 2/3 and 1/2. On the back, you will do all questions. For number 1, name a pair of fractions that uses the least common denominator and are equivalent to 9/10 and 5/6. So again, you have to use the LCD to create your equivalent fractions, just like you have to on number 8 on the front. Number 2, this is a multiple choice on Schoology. It does say Joseph says that there are 5/8 of a ham sandwich left and 1/2 of a turkey sandwich left. What is not a pair of equivalent fractions for 5/8 and 1/2? So this is a multiple choice question on Schoology, so you will want to have that up and open while you are solving number 2. Number 3, Matthew had the following times in 2 races. So he had 3 and 32 thousandths minutes and 3 and 23 thousandths minutes. They want you to use the greater than, less than, or equal to make the sentence true. Number 4, Olivia's class collected 3,591 bottle caps in 57 days. The same number of bottle caps were collected each day. How many bottle caps did the class collect per day? Because we need to find out per day, and we know the total number of bottle caps was collected, and we know that it was for 57 days. This is a division problem. You will not get a remainder, so if you get one, please make sure you resolve. Number 5, Elizabeth multiplied 36 hundredths by 1 8/10. What is the correct product? So remember, when you are setting up your multiplication problem, the decimals are not lined up. And when you go to place your decimal in your final answer, you know that the top factor has 2 decimal place values. The bottom factor only has 1. So your final answer must have a total of 3 decimal place values. And finally, for number 6, they want to know what the value of this expression is. Don't forget, you are using your PEMDAS. Please excuse my dear Aunt Sally. Remember, multiplication and division is whatever one comes first, left to right. Same thing with addition and subtraction, whatever one comes first, left to right. If you have any questions, let us know.